9. Right. In question number 9, first part we proved. Right. Question number 9, first part we proved, that is the relation this. Right. Okay. Now, next part.
Oh, sir. Oh,
Right. Okay. Now, secondly given, if 2GA less than u square less than 5GA, particle leaves a circular motion and moves as projectile motion under gravity. Okay. Now, you know, when the particle leaves the circular surface, we know in the earlier question, in the earlier theories, we said what? This can happen. This can happen after this point, before this point. That means in terms of theta, theta greater than 90, less than 180. In that interval of theta only, this can happen. The event that happening, people occurs due to that R becomes 0, right? So why? As long as the particle is in contact with the inner surface, right? As long as the particle is in contact with the inner surface, the R has a positive value. When R equals 0, only people, the contact loses. So at the moment the particle leaves this surface and begins to move in the gravity as a projectile motion, at that moment R is 0. Right? That moment R becomes 0 occurs after this level, before this. Okay? Right. So then we have to first put R 0. Right? We can write when the particle leaves the surface, R equals 0. That's what you can write. Right? When the particle leaves the surface, R equals 0. Right? You can write when the particle leaves the surface, R equals 0. Then put R0 here. Mu squared by A plus mg times 3 cos theta minus 2 equals 0. Right. The mu can cancel down. Right. So you can take this right hand side. E times 3 cos theta minus 2 equals minus u squared by A. Right. Then bring this E here. 3 cos theta minus 2 minus u squared upon dA. Bring this to the right hand side. That will be plus 2 minus u squared upon dA. Now take common denominators here, because dA, and you can write cos theta equal to dA minus u squared divided by 3dA. This is the cos theta. This is the cos theta, right? But you know, when the particle leaves, that occurs between theta less than phi and more than 90. Okay? Less than phi and more than 90. Okay. Right. And now write leaving the surface occurs when theta less than 5, greater than 5 by 2. You can take cos, taking cos, what do you get? Cos 5 by 2, cos theta, cos 5. This inequality we get, right? This inequality we get, right? Right, now cos pi by t is 0, people. Cos theta is this 2ga minus q square divided by 3ga. Cos pi is minus 1. We multiply this by 3ga, this will be 0. 2ga minus u square minus 3ga. Now subtract 2ga, subtracting 2ga, here we get minus 2ga minus u squared minus 5ga. Now multiply by minus sign. We get 2ga less than u squared less than 5g. This is how we take the answer, right? This is how we take the answer. Right, take the answer there. We come to the next part. Okay, read the next part. Yeah, now here, show that the minimum of R occurs at theta equals 5 and find minimum R. Hence, reduce that if u square greater than 5ga, the particle describe complete circles, right? For this R to be minimum, by using the expression we got for this, right, R, we can determine the minimum value of R. The minimum value of R we can take like this. Right, now this is our R. For this R to be minimum, okay, this R to be minimum, we can understand this mu squared upon A is a constant. Only this theta is the variable on the right hand side. Then for this R to be minimum, this right hand side should be minimum. No? Then this is a constant. Mu squared upon A is a constant. Mg also a constant. 3 and 2 constant. So therefore, in order to minimize the right hand side, definitely cos theta, should be minimum. Cos theta should be minimum. But you know, the minimum value of cos theta is minus 1. No? You know the cos graph, no? The cos graph is no, cos 0 is 1, cos 180 is minus 1, and so on. This cos theta is the theta axis. Here, this highest value is 1, lowest value is minus 1. No? Okay. Then the minimum value this cos theta can take is minus 1, right? So then you can write for capital R to be minimum cos theta is the minimum. But cos theta minimum is minus 1, right? Cos theta minimum is minus 1. This implies cos theta minus 1 means equal theta is 5. Right. When theta is 5, the normal reaction takes the least value. Theta equals 5 means people, this angle should be 5. That means when the particle reaches to the highest point, the normal reaction is minimum. People, what is the condition required for this particle to move in complete circle? At the highest point, the normal reaction could be positive. The same condition in the previous question, we discussed the condition required for the particle to move in complete circles easily. we said at the highest point, the tension should be positive. In this case, we have the normal reaction. The normal reaction at the highest point should be positive. Then what happens? The particle will move in complete circle. Then you can write introduce that if u square greater than 5Ga, the particle describes complete circle, right? Okay. We have the first find people at theta equals 5. That means the minimum value of r. Then r at theta equals 5. At theta equals 5 only, r will take minimum. That means r minimum is this. R theta equals 5 is the r minimum. So therefore, r minimum can then be found how? Put in -1 here. mu squared divided by a plus mg times -3 -2. You may put cos theta -1 here, -3 -2, right? So mu squared upon a minus 5mg coming. This is the r minimum. That means at theta equals 5, r value is this. That r minimum we found. R minimum we found. Now what is asking next? Hence reduce that if u square greater than 5Ga, the particle describes complete circles. What is the condition required for the particle to complete the circles? For the particle to complete circle. What is the condition required, people? R at theta equals 5 with them. It is this, no? Therefore, mu squared upon a minus 5mg should be greater than 2 and now u squared by a greater than 5g taken to this side u plus u squared greater than 5ga. Right, that's how we take that answer. Right. Now we'll come to the next question. Question number 10. Read in your tutorial, question number 10. Right. Read next part, people. Question number 10. A circular smooth tube of radius simple a center O is fixed in a vertical plane. A particle of mass simple m is placed at the lowest point A of the tube and is given a horizontal velocity u. At time t equals t, particle acquires velocity v, making an angle theta with the downward vertical. By considering the level of O as the potential energy zero level, obtain the equations this. People, in this case, this circular smooth tube. Circular smooth tube means, people, first we take the straight tube like this. First we take the straight tube like this. Right, in that tube, there's a hole, no? Right. Now, using this tube, people, this way, by bending it like this, the circle is formed. Right? This is that circular tube. Okay? By bending this way, a circle is formed. Now, the particle of mass m is placed at the lowest point. Lowest point is here. Right? And it is given initial horizontal velocity this way. Now the particle begins to move inside the tube like this. Okay. In this case, the particle has no chance, people, to come out from this tube. Definitely, if the particle moves, that should definitely move in a circle because the particle can't come out from this tube. That means, in this case, we can't discuss the condition or the projectile motion of the particle after leaving the surface. Because in this case, particle should move inside the tube. It can't come out. So therefore, in this case, we can't discuss that occurrence, but leaving the surface, circular surface, and moving under gravity as a projectile motion, that occurrence, people, in this case does not occur. In this case, people, the possibilities are, according to the initial velocity size, the particle can oscillate like this. It can oscillate through acute angle, through obtuse angle. That is the first possibility. The other possibility is particle can move passing the highest position in complete circle easily and just. And the other thing, people, in this case, we can see another one. While the particle is moving initially, when the particle is given this velocity u, the particle will contact this surface, the outer surface. Then that rotation, as long as the particle contact the outer surface, the normal reaction will be pointing toward the center like this. Once the velocity as the particle moves this way decreases, one occasion, this particle will make contact with inner surface like this, right? Leaving from the outer surface, it will contact the inner surface. Then the normal reaction will be acting outward this way. That is another new question for this question. What is that? The moment and the position or the angle theta when the direction of the normal reaction changes. That is a new question for this part. Right? This has no that situation, leaving the circular motion and starting the projectile motion. That we can't discuss here. But in this case, we can discuss, right, the position or the point where the normal reaction acting on the particle changes its direction. That kind of question we get in this case, right? First, people will draw the diagram, right? Okay. We draw the diagram there. I'll take this diagram again. right? This particle, right? Velocity given u. This way, right? It is so here. Lowest point A on the of the tube band is given horizontal velocity u, right? At time t, particle acquires velocity v, right here. Normal reaction coming on the particle like this. Weight acts like this. Is the potential energy zero level? Asking to take that level as a PE zero level, right? Okay. Right now, in this case, again, we can apply conservation of mechanical energy and F equals ma towards the center. This is T equals 0 instant. This is T equals T instant. Right? By applying conservation of mechanical energy, right? Here, the total mechanical energy is half mu squared minus mga, right? Initial energy, right? Half mu squared minus mga equals half mu squared, right? Here, when we draw a line like this height is a cos theta minus ga cos theta. Right? M can be cancelled down, right? Multiplied by 2 and bring to the right hand side. 2 minus 2ga plus 2ga cos theta, right? We can take minus 2ga out. And minus cos theta. Fine. If we go same way, now you can apply people towards the center, right? If this angle is theta, Here also this angle theta. Then f equals ma at equals c applying f equals ma. What do you get? R minus mg cos theta m times v squared upon a, the centripetal acceleration. Huh? Now, take the right hand side, mv squared upon a plus mg cos theta. Substitute for this v squared by this m upon a, v squared means v squared minus 2ga 1 minus cos theta plus mg cos theta. Then we remove the bracket by multiplying by this m upon n a, r equals m squared by a. This and this, when you multiply, we get a cancel here. M and this make minus 2 mg 1 minus cos theta plus mg cos theta. Then here you can take mg out. You can take mg out. Then take this mg out. Minus 2 and this minus cos theta is 2 cos theta, and this cos theta 3 cos theta. And minus 2. This is how we take that, huh? Right. Next one. Show that the direction of R changes at the angle alpha cos inverse this. Our direction, when the direction changes mean, people, direction of R changes mean here, this R, the normal reaction acting towards the center. Direction of R changes mean this direction should be opposite. So this direction of R to be opposite, definitely this particle should make contact with this inner surface like this. See? After leaving from this surface, right, that particle should make the contact with the inner surface. People, this tube is a narrow tube. Narrow tube mean, what do you mean by narrow tube, people? Actually, the space inside the tube is available just to move for the particle like this. Okay. The diameter of the particle and the diameter of the tube are equal. Then very slight gap between the tube and particle available. Then first occasion, right? If this is the circular tube, right? This is the outer surface. Then the normal reaction comes here. Once the particle moves this way, one occasion, the particle will make the contact with the inner surface like this. Then the normal reaction going out from the center like this. Even now, when this particle leaves the outer surface, the contact between the particle and the surface will lose. That occasion R equals 0. Meantime, soon after R equals 0, particle will make the contact with the other inner surface, other surface. So therefore, the moment the particle will get the direction of reaction opposite, that moment is the moment of R becomes 0, right? When the normal reaction becomes 0, that is the moment the particle leaves the contact, loses the contact with the outer surface and make the contact with the inner surface. R becomes 0 means people, the particle tries to go away from the contact surface. Once it tries to move, the present contact surface, meantime, that will make contact with the other surface because the tube is very narrow. Understand? So therefore, that moment is R equals 0, right? The direction of the reaction changes when R equals 0, right? And then the answer is obtained like that. Huh? I can write. When the direction of R changes, R becomes 0. R is this. That means this. Huh? Substitute for this R. Mu squared upon J plus mg 3 cos theta minus 2 equals 0. Then you can cancel down. Then we are given that triangle as alpha, but I keep that as theta, right? The subject here takes the right hand side, g times 3 cos theta minus 2, bring this right hand side, it's minus 0 squared by a, bring this g here and take this to the right hand side. 3 cos theta is equal to 2 minus u squared divided by dA. Cos theta is equal to 2GA minus u squared divided by 3G. Then theta can be subjected. Theta equals cos inverse 2GA minus u squared divided by 3G. This is the angle at which the direction changes, right? Right. Next condition, people. Right. Show also that if u squared greater than or equal to 4GA, particle describes complete circles. Now can you give me the condition which is required for this particle to move in complete circles? People, in the earlier cases, when the particle is suspended by a string and when the particle was moving inside the spherical surface, we use the condition required for the particle to move in complete circle as at the highest point, the tension greater than 0 and normal reaction R greater than 0. Okay, that's the condition required for motion in complete circles easily. People, in this case, the condition required for the particle to move in complete circles, we can't give in terms of normal reaction. What reason? Normal reaction is, in this case, people, the particle is in contact with the outer surface of the tube or inner surface of the tube. One of these two surfaces, the particle definitely what? Contact. And the particle can't go away from the tube. So therefore, in this case, the condition required for the particle to move in complete circle at the highest point here, at the highest point, Now the particle should have a positive velocity or zero velocity. Positive velocity or zero velocity. If the velocity is positive at the highest point, very easily particle passes this point and move in the complete circle. If v equals 0, particle just pass the highest point and move in complete circle. So that condition, remember. This time, the normal reaction R definitely acts inward to outward. So therefore, in terms of R, nobody can give, in this case, the condition. This time, the condition required for complete circles is given by using the velocity v. Right? Then you can write. Right? Write on like this. The condition required for the particle to move in complete circles is the velocity v, at the highest point is either positive or equal to 0. Is either positive or equal to 0. Then first of all, we'll find the velocity at the highest point when theta equals 180 or pi. When theta equals pi, using this, we can find v square, this 1 minus cos pi. Cos pi is minus 1, no? Cos 180 minus 1, no? V square, u minus minus plus, we get 2. U square equals u square minus 4ga. Right? Now, v velocity at theta equals pi should be positive or 0. Positive means what, people? Very easily it passes highest point and complete the circle. Equal 0 means it just passes the highest point and but complete the circle, right? Okay, so therefore v equals 0 means the particle actually is about to stop at the highest point, but it moves in the circle, right? Then v theta greater than or equal to 0, then this implies what? V squared at theta equals pi greater than or equal to 0. Why? If something is positive or 0, its perfect squared also positive or 0, right? So v squared at theta equals pi greater than or equal to 0. So then v squared is this, no? U squared minus 4ga greater than or equal to 0. This gives us the required answer. U squared greater than or equal to 4. This is how we take that answer, right? Right, people, now Take question number 7 as the next. Take question number 7. Read question number 7. Right? Question number 7. Read question number 7 as the next question. Question number 7. A particle of mass simple m is projected horizontally with initial velocity u from the highest point on the smooth surface of a fixed sphere. Fixed sphere. This way. We have a fixed sphere like this. Now a particle is right. Particle is projected horizontally with initial velocity u from the highest point. This is the highest point. This is the center of the sphere. Highest point is this. This. Horizontally with the initial velocity u. Right? Right. Now, in time t, particle turns through an angle theta and acquires velocity v. Acquires velocity v. Right? In time t, particle, right? This way, particle moves on the surface of the sphere. Right? Now, it comes somewhere here. Right? That location, suppose the velocity is v, and the normal reaction come in to the particle and outward this way. And weight x mg. Mg, right? Obtain this. Right. In this question, people, we are not given a level to consider as what? Potential energy zero level. We can take any level, whichever the level you take as your potential energy zero level, we get the answer, the same answer correctly. Yeah? Right. So therefore, in this case, I am going to take the potential energy zero level as this position. That means point O, or else you can take it this also. When we draw this way horizontal line to the lowest point of the sphere, right? Okay. That also possible to take as the P is zero level. Hmm? Right, I'll take this level as the P is zero level. Right. So this also then A, right? Right. So then first thing is, if this angle is theta, this also theta. People here, this is P equals 0. And this is T equals T. Right. We apply conservation of mechanical energy. Right. What is that? T equals 0, that kinetic energy, half mu squared plus this height, A and A, 2A. mgh, no. mg is the weight, h is 2A now. 2, we write that, 2 mgh is the initial mechanical energy is equal to mechanical energy at T equals T. It is kinetic energy half mv squared half mv squared plus mg. When we draw a line like this, up to here, the height from here, this is A, this is theta, this is A, this is A cos theta. Therefore, this is A cos theta plus A. mg A plus A cos theta. By this, we can take the value of V squared, first answer. We can cancel down this m first. Multiply this by 2. Here u squared plus 4ga. Bring that to this side. Meantime, we can take this a out. Since we multiply by 2, that will be 2a now. When I take it this side, it is minus 2a 1 plus cos theta is equal to v squared. Then this u first, v squared equals this u squared. Here minus 2ga, when you remove the bracket, we get minus 2ga, 4ga minus 2ga is 2ga. And here 4ga, people will take this g 2ga out, no? That is much easier to simplify. When we take 2ga out, here we have 2. This we took out of minus 1 minus cos theta. Then 2 minus 1 is 1. Then v squared is equal to u squared plus 2ga 1 minus cos theta. First answer coming. First answer coming like that. Okay. Secondly, asking answer for R. We can apply F equals ma towards the center. Applying F equals ma. Towards center. What is that? mg cos theta minus R equals mg squared upon A. Then R can be subjected, take this side and bring this side. R equals mg cos theta minus mg squared upon A. Right? Then we can write R, substitute for this v squared by this. V squared is this. Plus 2ga 1 minus cos theta. When you simplify this, you can take this also far. Simplify this. R equals, remove the bracket by multiplying this m by a here, and multiply this and this, a and a you can cancel down, a mg cos theta. And this and this you can cancel down, plus and minus minus 2mg 1 minus cos theta, right? And here minus mu squared upon c. Right. You can take people here, mg out. Then here we get cos theta. Here when you take this mg out, here we have minus 2. Multiply this minus cos theta, we get 2 cos theta, and here cos theta 3 cos theta. And here minus 2. Minus mu squared upon c. This is how we take at R. Right. Now, a question is asking this way. Deduce that if u square greater than or equal to GA, is that if u square greater than or equal to GA, the particle leaves the surface at t equals 0. At t equals 0 means, people, at the moment we give the velocity u to the particle, that is the t equals 0 moment. T equals 0 moment means at the moment we give this velocity u to the particle is the t equals 0 moment. Now, people, you can very clearly understand, when we give a considerable higher velocity to this particle, the particle will not rolling over the surface. It will be directly moving horizontally like this and moves as a projectile motion under gravity. Moves as a projectile motion under gravity if we give a greater velocity to the particle initially. That moment also, people, when we keep this particle at the highest point, after that only we give this velocity, no. When the particle is actually given this velocity u, that location also the particle is acted a normal reaction like this, suppose S. Right? At the moment when we give this way a greater velocity u to the particle, people, if the particle leaves the surface and begins to move as a projectile motion under gravity, what happens with S is, people, at t equals 0, that means soon after giving the velocity u to this particle, if the particle leaves the surface and begins to move under gravity as a projectile motion, that occasion, people, the normal reaction is marked there. That normal reaction S is either 0 or negative. Why? The particle loses the contact with the surface of the sphere at the instant the velocity u given to it. Losing the contact means, people, R0 is the initial moment of the losing the contact. Thereafter, R negative means they separate. Okay. So therefore, at t equals 0, that means soon after giving the velocity, if the particle leaves the surface, at t equals 0, this theta particle is here, no? Theta is 0. Then putting theta 0 here, we can find this r. That answer for r is the answer of this is. Why? S is the normal reaction at t equals 0. At t equals 0 means, in this case, using this situation, if we bring this theta to 0, the particle will be here, r is s. So therefore, to find this s by using this result, we can use this result to find that s putting theta 0 here. When you put theta 0, theta becomes 0 means particle is here. Right. So then you can write the condition there like this. Right? Write it like this. At t equals 0, at t equals 0, if the particle leaves the surface, then the normal reaction at t equals 0, is 0 or negative, is 0 or negative. Is 0 or negative. Write down. Since at t equals 0, theta equals 0, we can put theta 0 here and find r. R at t equals 0 can be obtained putting theta 0 here. Mg 3 cos 0 minus 2 minus mu squared by 8. Cos 0 is 1. 3 minus 2 is 1, then mg here. Mg minus mu squared by 8 is the reaction at t equals 0. This should be either 0 or negative. R at t equals 0 less than or equal to 0. Put that here. Mg minus mu squared upon a less than or equal to 0. This we can cancel down. Bring this side. Just first multiplication this way. U squared greater than or equal to g. Greater than or equal to GA. Right. People, another part is asking there. What is that part? Right. Now, we found g times 3 2 minus mu squared upon a. Right. Right. Now asking next one, people. right? When you consider this condition, u is the initial velocity, no? If its perfect square is either greater than GA or equal to GA, what happens? Without rolling over the surface of the sphere, particles suddenly move under gravity as a projectile motion. If this u squared, this condition is not valid, that means if the u squared is not greater than GA, that means u squared less than GA, then particle does not begin to move under projectile motion. It moves on the surface a little distance and then begins the projectile motion. Right? People, in this case, since the particle is moving on the surface of the sphere, definitely the particle gives up the circular motion, right? One moment. The reason particle moving like this, people, and once it comes somewhere here, after that the particle can't move along this way, because the particle has the freedom to go away from the surface, because the velocity is projecting this way, pointing this way. Understand? Okay. So then, when the particle leaves the surface, right, asking to find that angle. When the particle leaves the surface, people, what happens? The contact between the particle and the surface will lose. Contact loss means the normal reaction first becomes 0. When the normal reaction becomes 0 only, people, the particle begins to what? Leave the circular motion. That means it begins the projectile motion, right? And then you can write, when the particle leaves the surface, R equals 0. R equals 0. Right? R equals 0. Put R equals 0 there and find this angle asking. In this case, people, the particle never complete the whole circle. Particle never complete the whole circle. Particle has no chance to complete the whole circle, right? R equals 0. Put R0 here. Mg, R I am searching for R. Mg 3 cos theta minus 2 minus mu squared upon A equals 0. M you can cancel down. Then 3 cos theta minus 2, take it to right hand side and divide by G. U squared upon GA. Then cos theta you can write 2 plus U squared upon GA divided by 3. This is really U squared plus 2GA divided by 3GA. It is theta cos inverse U squared plus 2GA divided by 3GA. For this angle theta given in the question as alpha. Right. With initial velocity r, asking the velocity of the particle when it leaves the surface. That can easily be found, people. When the particle leaves the surface, we know the cos theta value as this. Now we need the velocity of the particle when it leaves the surface. To find the velocity, people, we need the value of cos theta. But we know the value of cos theta when the particle leaves the surface. It is given by this. Then this figure we put here. Then we get the V. Right? We get this V. Right? Then we can find that. Okay. Right. Now, using that equals Q square plus 2GA 1 minus cos theta. Substitute this cos theta by this answer. Q square equals U square plus 2GA 1 minus cos theta is this. Q square plus 2GA divided by 3GA. Then you can simplify this. Multiply by this 2GA minus by 2GA when you multiply here. GA and GA you can cancel down. We get 2/3. U square plus 2GA. Right now? Now we can take here common denominator as 3. Then this will be 3U squared. Here 6GA. Remove the bracket 2U squared and minus 4GA. V squared equals 3U squared minus 2U squared is U squared. 6GA minus 4GA is 2GA. Divided by 3. Then we get this V as the root of 2 square plus 2GA divided by 3. This is the velocity with which the particle leaves the surface, right? Okay. Now, in the subsequent motion, right, after leaving the surface, the particle now moves under gravity as a projectile motion. Now, suppose this is the instant the particle leaves the surface, and then velocity V is this way. No? The velocity V is always along the tangent, no? Along the tangent, this way. Now, particle moves as projectile motion under gravity like this. And then particle hit on the horizontal plane. Right. Find the horizontal displacement of the particle when it falls on the plane. Horizontal displacement means, people, here. Horizontal displacement means this part plus this part. This part we know, what is that? A sin theta. This part, no, this is A sin theta. Horizontal displacement mean initially it was here, no, finally here, right? When it falls on the plane, right? Horizontal displacement means initially here, finally here. That the particle has moved to right, this length plus this length. This is A sin theta, and we need to find this. Suppose this is S. This S can be found by applying equation of motion, right? Here we get a bit long simplification. What is simplification? First of all, to find this S, we have to calculate the time the particle takes to reach the horizontal plane. By applying equation of motion, we can do that. How to do that? The time we have to find. Yeah, people have to do this now. We can first apply s equals ut plus half a2 squared. Applying s equals ut plus half a2 squared downward direction for the particle after leaving the circular surface until it reaches the horizontal plane. What is this height? This height going to be, this is theta, therefore this is a cos theta plus a, right? This s is a plus a cos theta equal this velocity, what people? V sin theta. Downward, no? V sin theta ut times t plus half dt squared coming like this. This is the quadratic equation in t now. To find this t, we have to solve this quadratic equation, right? We'll take this as number 1. Now, apply s equals ut rightward. What's that? S is this. Velocity u means here, this is theta, 90 minus theta, horizontal component going to be v cos theta. V cos theta times t. Times t. This is number 2. By solving this 1 and 2, right, we have to find what people? S. We have to find S. Right. The answer of V is this now. Huh? We have to put that where here. Cos theta is this. Right. Thereby, people, right, you have substitute for this V and sin theta also. Actually, when you try to solve these two equations, the simplification is too long. Right. Now keep here the question. Why in solving this long simplification coming, right? So this is how we apply the equation of motion. If this is, if we can find the t by solving this equation, putting that pair here with the value of v and cos theta, you can find this s. Then a sin theta plus s is the horizontal displacement. That part you can do, but don't go to that because the simplification is too long. Right. Now, try to do the rest questions in the tutorial as homework. Now, almost all theory is finished, but I must do more sums in the lesson, right? Some more questions available in the lesson, right? You must do those questions as homework now. The theory is now finished, right? Theory is now finished. Okay. Then we come to the end of the lesson.